Here is what happens when a language model produces a single token. The model takes the entire sequence, so far every token of context, plus every token it has already generated, and feeds it through every layer of the network. For a 753 billion parameter model like GLM5, 2. The activations flow through dozens of transformer blocks. Each block multiplies massive weight matrices against the current hidden state, computes attention over the sequence, applies nonlinearities, and pushes the result forward to the next layer. At the end of that forward pass, the model produces a probability distribution over its full vocabulary, roughly 150,000 possible next tokens. It samples one. That token gets appended to the sequence. Then the whole process starts over for one more token. That repetition is the bottleneck, and it is not the kind you can solve by adding hardware. Each token depends on the one before it. Token 3 is part of the input that determines token 4. Token 4 shapes the distribution for token 5. The dependencies are sequential by construction. You cannot compute token 10 until you have committed to tokens 1 through 9. This is autoregressive decoding. And during generation, it is not compute bound. It is memory bandwidth bound. Think about what the GPU actually does during each forward pass of generation. It is not performing the massive parallel matrix multiplications you see during prefill, where thousands of tokens get processed simultaneously. It is loading billions of parameters from high bandwidth memory, multiplying them by a single token's activation vector, and writing the result back. The arithmetic intensity, the ratio of useful compute to memory traffic, is tiny. The GPU's thousands of compute cores sit mostly idle, waiting for weight matrices to stream in from memory. This is the fundamental asymmetry of transformer inference. Prefill is compute bound. You have a big batch of tokens, and you can saturate the GPU's math units. Generation is memory bound. You have one token, and the GPU spends most of its time reading weights it will barely use. On a modern GPU, an H100, an A100, whatever your serving cluster runs, a single decoding forward pass for a model this size takes roughly 20 milliseconds. That sounds fast. It is not. An agent does not generate a few hundred tokens. An agent generates tool calls, reasoning chains, code blocks, error traces, diagnostic outputs, and corrective actions. A single agentic turn routinely produces tens of thousands of tokens. Do the arithmetic. 50,000 tokens at 20 milliseconds per token is 1 million milliseconds. 1,000 seconds. Almost 17 minutes of pure generation time, not counting prefill, not counting tool execution, not counting network latency or API calls. Now scale that to a real workflow. A legal matter pipeline routes a question through extraction, analysis, contradiction checking, and synthesis. Each worker step might generate 5,000 tokens. 10 worker steps across a matter produces 50,000 tokens of generation. At the naive rate, that is 17 minutes of sequential forward passes just to produce the output. But that is one question. A real matter has 50 questions. 50 times 17 minutes is 850 minutes over 14 hours of pure token generation for a single matter. Not counting reading, not counting tool calls, not counting review cycles, just the forward passes required to write text.